Hello, friends. Welcome to this live session of multivariate procedures with R. Right. Okay. So now the next question comes: what motivated me to float this course or to record this course? Right. So one thing you will see that in real life, whenever you are trying to deal with any statistical topic, this is always multivariate. And there are hardly any outcomes in which we can say that it is affected only by one variable, one outcome. Dealing with one outcome or one variable is pretty straightforward and easier, simpler. But as soon as we try to work with more number of variables, then the complication starts. And then there will be interactions. There will be more variables. They will have inter-effects. And so whenever we are trying to work in a multivariate setup, so whatever we were studying in a univariate setup, that will be there. But beside those things, their interaction and their joint effects will also be there. And that makes a big challenge. For example, in case if I have three variables, x, y, and z. So in case if I study only x, y, or z, then okay, it's straightforward. But when I'm trying to take x and y, then I will have the effect of x, effect of y, as well as the joint effect of x and y. But as soon as I add one more variable z, then we will have x, effect of x, y, and z, as well as joint effects of x, y, y, z, and x, z. Also, the joint effect of x, y, z. And if you have four variables, such joint effects will increase. And definitely, uh, you can't ignore them. They are the variables which are going to affect the process. For example, if somebody has only high blood pressure, that person may have certain effects. But if someone has high cholesterol, diabetes, as well as high blood pressure, then this type of three different factors may have a joint effect which might be more complicated, that may give rise to more complicated issues. So that is why it is very important for us to understand the multivariate procedures. Now, when you come to the multivariate, then another popular topic is multivariate analysis, but I have used the word multivariate procedures. Multivariate analysis, I have not used it intentionally because when you come to statistics, then there is a multivariate analysis topic, and under which there are some special topics which are only there. But when we are talking about multivariate procedures, then the statistical topics are coming from different areas, different fields, which are the topics where the number of variables are simply more than one. So that is why this is a more general name, and I have considered different types of aspects in this course. Well, yes, one of the biggest challenge for me in developing this course was that when we try to teach the courses on, say, this multivariate procedures or multivariate analysis in a physical classroom, then the students are usually they have a training in statistics or other subjects in the past for a couple of years. For example, if you are in the BSc final year or say MSc statistics final year, only then this multivariate topics are taught. So students already have learned many things in the past. So whatever the requirement are there to learn the multivariate procedures, they become they are already actually there. But in my course, when I was trying to develop, I don't wanted to put this condition that a student should know each and everything in statistics before they come to this course. So that is why you will see that some time and some part of the course was devoted to the univariate. And the idea was that I wanted to give you the basic concepts, utility, and interpretation of different types of tools in the univariate case. And it is easier for me to explain you, and it is easier for you to understand when we are talking in terms of univariate setup. As soon as I go to a multivariate setup, things are not visible from our eyes in most of the cases as the dimension increases. And then many things you have to use your brain to visualize them. So if you don't have the idea or the interpretation or the utility in the univariate dimension, it will become challenging for you to understand in the multivariate dimension. So that is why before every topic, I took the univariate setup and then I translated it to a multivariate setup. And since this was the objective of the or the aim of the course was more towards applied uh, application rather than the theory, so I have tried my best to keep the levels of the theory to be as low as possible. And then I have tried to means pick up different types of topics from different areas and to uh, keep them together. For example, when I'm talking only about the it, test of hypothesis and say this analysis of variance. Analysis of variance also a test of hypothesis. So I start with one variable case, say S naught mu equal to mu naught. Then I come to a two variable case, S naught mu one equal to mu two, and then I come to the analysis of variance, which is more than two population. That is S naught mu one equal to mu two equal to say mu p. And then I try to convert it into a multivariate setup. Although I could not do it because then we you will have a multivariate ANOVA, and multivariate ANOVA is just like usual analysis of variance. But then, yeah, due to the limitation of the time, I could not do this multivariate ANOVA. But the way I developed it, I wanted to make sure that all the students who have approach the understanding from univariate to bivariate to this the more than two population, that can be that they can extend it very easily to the multivariate setup also. That's my promise to you. And the same thing I have done in most of the cases, because if I try to take all the cases over there, then possibly I did not have time, or then I would be concentrating only on, say, this with very selected limited number of topics only. So whenever you are trying to learn any multivariate topic, you have to understand one thing, that you should know or you should understand what is happening in the univariate case, and then try to think yourself in a way that that how the multivariate things will look like, and then you have to translate it into a multivariate setup. And in that case, this matrix theory, vector analysis, etc., they are going to play an important role to when you try to translate it to univariate to multivariate. And yeah, the more important part comes that that how to use them based on any software. So for that, I have used the R software here, and I have tried my best to give you an idea that how you can use this statistical tool with the help of R software. Right. And one thing I can tell you about this R software, that in order to do one small thing, there can be more than one packages. But the outcome will be the same. The statistical implications and then the statistical outcome will remain the same. The reason being because R being the free software, so different people across the world, they are trying to develop different types of packages, and they are trying to add more features. So you can use any of the package. For example, if I want to conduct the Hotelling P-square test, then although I have used only here one package, but then there are more than one packages which are available. So I will not actually mind that even if you use any of the package. But definitely, when I am trying to give the assignment, then I have prepared the assignment based on the same packages what I have demonstrated during the lectures. So this is what you have to keep in mind. Means another important thing which many people have asked on the forum also, that during the examination, will you get the R software? So answer is no. During the examination, our software will not be available. And the reason is very simple, that because the examination is going to be conducted on some online platform in a computer-based test mode. So for that, a special type of this operating system is used, and in that operating system, R cannot run. So as soon as in the future we will have this possibility to include R in that one, then we will definitely do it. But at this moment, you need not to worry. The examination questions will be based or will be created in such a way such that we can judge your knowledge on the art software without using the art software. Now, how to do it, that is my challenge, that is my responsibility. So you can believe on me that the question paper will be in a way which you can understand and can attempt it. My objective is to test your knowledge, not to penalize you. This is what you have to always keep in mind. Yes, calculator will be there, so you can make simple calculations over there. But then anyway, usually you will not need even the calculator also if you can do small calculations. Right. So this is about the examination. Yeah, and the examination will be of multiple question times. That there will be four alternatives. So and then you have to solve, and then you have to identify the correct alternative. So that is how the question paper will look like. Right. And yeah. And now coming to the questions, Pragya has asked, respected Shalabh sir, kindly tell the R command that can be used for the t-test for the equality of means and difference of means when the pair sample are of unequal length and their variances are known and different in values. Suppose XY paired sample are given and the length of X is 9 and length of Y is 6 and their standard deviations are sigma X equal to 40 and sigma Y is equal to 60. I have seen all your lectures, but I cannot find the suitable R command that can be used for this purpose. In those lectures, the R command is given for known and equal variances. Please resolve my this doubt. Thank you. Okay, Pragya. Now I will try to divide your questions into several questions. Number one, when you are talking about t-test, so t-test can be for one sample, that can be for two sample or more than, yeah, like this. So when you are talking of this two sample test, then you have two options, that you have two random variables on which you have obtained two independent sample observations. Right. Suppose I try to take the heights of the students in, say, this school number one and school number two. So you try to take a sample of, say, this size 20 from school number one and sample of size, say, this size 40 from school number two. And now there will be two options that they have been drawn from the same from the normal population, and the variances of the two population, that is school one and school two, they are equal. And the second option is they are unequal, right? So first, let me try to address this question, and then I will try to come to your this paired observation issue. So now, definitely, uh, I can give you the basic fundamental. If you're aware about the statistical tool, then you know that if X is a random variable which follows a normal distribution and Y is a random variable which follows a chi-square distribution, and suppose X and Y are independent, then the distribution of X divided by square root of Y divided by N follows T distribution. Right. So this is how we derive it mathematically. So when we are assuming that we have two populations and the population variances of both the population are the same, they can be unknown. Then we are able to get here a test what we have described here as a two sample test, and this is a uniformly more powerful test, no issues. And no, no, and then the question comes, in case if the variances of the two populations are not the same, then in that case we find some difficulty in deriving the probability distribution of the test statistics. And in this case, we face some problem and then we have to make certain compromises. And this problem is called as Fisher-Behrens problem. So if you try to see if you have two cases when the samples are coming from two normal population with equal variances, then absolutely no issue. Then you can use this t-test. When you have when the samples are coming from two different populations, they are independent, but their population variances are different. Then this is called as Fisher-Behrens problem. And for Fisher-Behrens problem, we have a test statistics, and its distribution is given in the book, and we try to conduct the test of hypothesis using that statistics. Now, when you come to the R software, so R software, uh, if you try to see, there's an option var dot equal, that is equal to true or false. So in practice, it is very easy to employ that. If you assume that the samples are coming from the two population whose variances are the same, then you simply have to put var dot equal is equal to true. And in case if the observations are coming from the two population whose variances are different, they are not the same, then you have to simply write var dot equal is equal to false. And then the R software will accordingly choose the correct statistics, and it will try to um, and then it will try to give you the uh, correct correct answer, right? So this is about this thing. Now I come to your second part. The second part is that you are trying to have the paired observations, but you are trying to have different sample sizes. Well, my question to you is that, is it possible? No, this will not happen, because the concept of the paired observation is that if you are trying to take one sampling unit, then you are trying to take two observation on the same sampling unit. For example, in case if I want to see inside a classroom, there are suppose 20 students, and I give them some test on mathematics. Then I try to get their scores. Now I try to give them a training, some extra training in mathematics for about a month, and then I try to take the examination on mathematics, and then I try to get the score. So what will happen is student number one. Student number one will have 2 marks, one before the training and after the training. And similarly for the student number two, there will be 2 marks, one before the training and second after the training. And the same story will continue up to student number 20. So all the 20 students will always have the 20 observation on the marks before the training and 20 observation on the marks after the training. So there cannot be a case where a student will have means one set of observation will be smaller than the other. So that is why this will not happen. In the paired observation, there will always be equal number of this uh, uh, observations. Definitely, when you are, and this is actually done by paired t-test. So in the paired t-test, the assumption is that the population variances, they are from the 2-1. So in case if you think that the variances are also different, then you have to define test statistics similar to Fisher-Barron problem statistics, right? So that is why. But in that case, inside the R software, there is an option here, paired is equal to true or paired is equal to false. So if you have paired observation, then the R it will work only when there are equal number of observation in both the samples. And then in case if you try to choose the variance dot equal is equal to false, then it will try to give you the outcome based on the paired t-test when the population variances are also uh, different, right? So this is the thing. And yes, whatever test I have given, they are based on the normal distribution. That means my x's or my random variables are continuous. In case if I have got different distributions, say there's discrete, then this test will be somewhat different, right? So that is my answer to your question. Um, now, yeah, there is another questions. Am I me? Okay, sir. When to use ANOVA and ANCOVA? Okay, analysis of variance is say this analysis of ANOVA is analysis of variance and ANCOVA is analysis of covariance. Right. So in this means this lecture, I have given you the idea of only analysis of analysis of variance, and I have not considered the analysis of covariance. So at this moment, yeah, if I try to give you the idea of ANOVA and ANCOVA, I'm sure that you will not get uh, confused. So I think better is to you can write me separately. I will give you this idea. Otherwise, a forum may create some confusion. So I mean, you can just send an email to me. I will give you the link from where I can explain you very easily. Right. Otherwise, many people will get confused because I cannot explain it in a minute or 2 minutes. That will make more say this complications rather than the solution. But definitely it is, I can assure you it is not difficult. And the way we try to use this analysis of variance, similarly, we can use the analysis of covariance also. The next question is Sharat and the like. Typically, we assume that the random variables are IID in a multivariate normal distribution. On what basis we assume this? Does this assumption work for real data set, other discrete continuous random variable? Good questions. Which are the most usually latest? Okay, first let me try to give this idea. So, okay, Sharid is asking that we always assume, make an assumption that my observations are IID, that is identically and independently distributed. So, so why this assumption is needed and actually how it comes. So, Sharath, my simple answer is that you see mathematical tools or I will say statistical tools, whatever we are using, they are not coming from the sky. They have to be found using the mathematical tools. And when we try to derive these tools, then we are doing some mathematical analysis. So when we try to assume that the observations are independent, then in particular managing the likelihood function become easier, and the likelihood function can be expressed as the product of individual probability density function, right? And when we are trying to use that they are identically distributed, that means all the random observations they are following the same probability density function. So that means now the likelihood function, which in case of independent only, that become the product of individual probability density function. And when you try to additionally assume that they are identically, then all the probability density function, they also become the same. And the mathematical handling of those expressions become simpler for us. So that is how we try to, so all these tools, whatever we have used, wherever we assume that the observations are IID, that means the tool have been derived by using these concepts. Well, I'm not saying that there are not tools which are valid when these assumptions are violated. So we have a statistical tool that when the observations are not independent or even not identically contributed. But those tools are different than the tools which have been proposed or explained in this course. Right. So if you want to go through with those courses, I would suggest that you can look into the books. And then depending on whatever tool you want, they can give you different types of tools. For example, if I say a very simple example, we have center limit theorem. So you will see in the books that we have center limit theorems for independently distributed observation as well as non-independently uh, distributed observations. So then the tools are going to be different. And number two, when you are trying to discriminate between discrete and continuous random variables, yes, so there will be many tools which may differ when the nature of the random variable changes from continuous to discrete or vice versa. So for discrete random variables, we will have different types of tools, and for continuous random variable, we will have different types of uh, tools, I would say. For example, in the case of regression analysis, you will be doing the multivariate regression analysis as well as logistic regression analysis. So when your Y is continuous, then you follow the multiple linear regression analysis. And when your Y is say this dichotomous, taking only two values, 0 and 1, then we try to follow the logistic regression. And then you will see that the interpretation of the regression coefficients in the multiple linear regression model as well as logistic regression model, they are very different. So different type of variable, different tools, right? That's my message. Your next question is, which are the mostly used and latest multivariate procedure in real world AI data science and application? Yeah, it is Miss, I will say all are important. It all depends on the nature of problem, what you want to solve, and without any prejudice, I will say that all tools are very important. It just depends on upon the situation, what you want to use. Sometimes you will be using the cluster analysis, sometimes discriminant analysis, sometimes regression analysis, or sometimes even a combination of them. Right. So all these processes, which so I will say in a very simple way that whatever tools I have means explained in my this course, definitely they all are important. That much I can say, and that is how I have chosen them or collected them to be included in this course. The next question is, sir, how will the advent of smarter ML methods going to impact the relevance of the manually understanding and applying multivariate procedure for both industry and research perspective? Excellent question. You think? Yes. If you try to see, whenever we are trying to talk of ML models, machine learning models, what this machine is doing? What machine is doing? Nothing. If you are sitting before the laptop or before a high speed internet, sorry, this computer cannot do anything. This is only you guys who has to first make a program. And when you have to write a program, then the question comes, what to program? So the next question comes, depending on the problem, you should have a problem solution which has to be programmed. Now the problem solution will come from where? God will not send it to you. God will not come before you to, yeah, give you the solution. But this is only you who has to find, who has to first think that, okay, what can be the possible solution? And now, in order to understand, you have to first understand the basic principle. For example, you should know where are you going to use multiple linear regression analysis, where are you going to use simple linear regression analysis, where are you going to use discriminant analysis, where are you going to use principal component analysis, where are you going to use cluster analysis. Only then you can decide and say understand. When we are talking of improvement in the smarter, what you have written the word, the smarter ML methods. So the thing is, this basic fundamentals are coming from only from the basic sciences. When my data size is becoming very large, and then definitely we need some machine learning models who can do the job automatically, because as a human being, it will take a very long time for us to solve it. For example, if I want to invert a matrix of say million by million order, manually I cannot do it. Now if I want to program it, then there are different algorithms for the inversion of the matrix. They all will give the maybe the same outcome, but their rates of convergence may be different. So any process which gives us the solution more precisely in the minimum time or in a faster way, that will be a smarter ML model or say ML process. So now the machine learning models may be changed depending on the capability of the programmer and the availability of the new algorithm based on certain new logic. But the basic principles behind those machine learning models will remain the same. So that is why it is very important to understand the basic fundamentals of the multivariate procedures so that you can use them at the right place. It is something like this. In case if the doctor does not know what are the chemical compositions of different combinations and how different chemical substances are going to affect the body, do you think that the doctor can make a right combination of the chemicals to convert them into a suitable medicine? Answer is no. So that is why it is important for us to understand the basics, fundamentals from the theory, and then after that, it is your choice whether you want to employ them in the industry or in the research or both, right? So without these tools, basic fundamental tools, you cannot understand the this multivariate procedures from the fundamental point of view. And I always say you have to decide whether you want to become a compounder or a doctor. I always say that become a doctor who will always try to take a wise decision, and compounder will only be following the advice and the instructions of the doctor. Okay, then there is another question. K. Upendra, sir, when to select with and without replication options in ANOVA test? It all depends on you. That what type of circumstances you have or what type of data you have. Whenever you are trying to replicate the data, then it is trying to give you the estimate of the within group data variation also. Right. And then, yeah, means those variances can be is estimated more precisely when we have repeated observation. For example, I will give you a simple example. Suppose you want to find out the age of the or the suppose age of the people. Right. Now, if you ask me, I will say, okay, my age is 20 years, but it is not 20 years. It is something like more some plus minuses. So if you try to ask my age three times, four times, possibly if I don't even remember, you can judge my age by these different types of people. They can look at my body structure and give some value. Somebody may say this 20 years, somebody may say 21 years, etc., etc. So you will get a more say this precise value when you have the this repeated observation. And the choice to have repeated observation with and without, it is not the choice of the statistician. It depends on that what type of data is available to us, right? So then, Sharat, like, what is the difference between multivariate random vector and multivariate random matrix in terms of concept and structure? Yes, good question. You see, if I try to say yes, let me try to take the example of multivariate normal distribution. So in the case of multivariate normal distribution, you have two parameters. One is about the mean vector and say another is covariance matrix, right? So when you don't know their values in practice, so what we try to do, we try to collect some data and using, for example, maximum likelihood estimation or any suitable estimation procedure, we try to estimate the mean vector and covariance matrix, that is mu and sigma. So now if you try to see mu is a vector. So when you will try to estimate, then obviously you need a vector quantity. So we try to estimate mu1 by x1 bar, mu2 by x2 bar, and we try to create a sample mean vector. So a mean vector is going to be estimated by the sample mean vector. Similarly, if you try to attempt that how are you going to estimate the covariance matrix. What is the covariance matrix? Uh, the covariance matrix is an arrangement of the variances and covariances on the diagonal and off diagonal of a matrix. Right, all the variances are represented on the diagonals, and all the covariances they are represented on the off diagonal of the matrix. So when you want to, and then yeah, because they are matrix, so they also have one additional information, that is the addresses of the respective values. For example, variable number two's variance will be on the second diagonal element only, and the covariance between the first two variable will be on the second place in the first row and the second place in the first column only. So when we are talking about the matrix will have elements along with their addresses. So when you want to estimate the covariance matrix sigma, that means there has to be an estimator which is in the form of a matrix, right? So if I have a matrix of order, say n by n, then the estimate of the matrix will also be of the order of n by n, and the whole matrix is estimating the whole matrix. So that is the difference between the estimator of a parameter when the parameter is in the form of a vector and a matrices. For example, if I try to say in the case of multivariate normal distribution, the sample mean vector is the estimator of the mean vector, and sample covariance matrix is the estimator of the covariance matrix. And after this, if you want to understand, I can tell you that the sample mean vector will follow a multivariate normal distribution with the same vector mu and covariance matrix sigma by n. And the estimator of the this covariance matrix, which is a matrix itself, that will follow a Wishart distribution. Although I have not covered it here, but the name is Wishart, Wishart. So this is how the things actually changes, right? So that is what the concept is the same, but the structure and the structure of the statistical tool, the way we try to take the correct statistical outcome of that, how to interpret them, they also changes when we are trying to move from univariate to vector to matrix, right? Okay, then the next question is from Amin. Sir, the target number of observation in air pollution studies P values are always less than result because wait. Sir, for large number of observation in air pollution studies, P values are always less and result become statistically significant. Is there a limit on the number of observation we should use? Well, that's a very philosophical question, I would say. In statistics, we always believe that if you have a larger number of, say, observation, yeah, I believe that the observations are correct, then your statistical inferences will actually improve. So if I say as a rule of thumb, if there is one statistical inference which is based only on 100 observation, and say another statistical inference which is based on 1000 observations, then possibly I will believe more on the inference which is based on 1000 observations. And actually, this is coming because of the property of consistency of the estimators, right? So in the that whenever we are trying to estimate a parameter, there is always a concept of consistency of the estimator. And we always say that, okay, as if my parameter is theta and that is estimated by theta hat, if theta hat is consistent, then as we try to increase the sample size, the estimated value will tend towards the true value. So in a sense, when you have large number of observations, you can expect that the value which you are going to estimate, it is more closer to the true value in the population which we don't know. So that is the basic concept. Now, there is no means. I said your question is more philosophical because that's an open question that how much small it is small and how much big is actually large. Right. So it depends on, say, tools on the application and the nature of data, that how much sample size we can consider as large. So the way I try to work in my issues is that I always try to conduct a sort of simulation. Right. So for example, if I try to conduct I will try to use the same procedure which I want to use in statistics, and I would try to use it for, say, sample size of, say, 10, then 30, then 100, 2000, 5000, and so on. And then I will try to see that as I am trying to increase the sample size, whether the estimated value is converging toward the true value or not. Because in the simulation, we are trying to generate the artificial data. So we also know the values of the parameter which from which we have generated the data, and we are trying to estimate the same parameter which is known to us through our statistical process. So in case if I say, suppose I have generated data with, say, mu equal to 100. Now, in case if I try to take a sample of size 20 and if I try to estimate my sample mean, suppose sample mean comes out to be 80, then I know that the actual value is 100 and the estimated value is 20. Now I try to increase my sample size to suppose 100. Now this value suppose comes closer to, say, this 90. Then I try to increase the sample size to suppose 1000. Suppose it comes closer to this, suppose 98, 99. And then I try to change from 1000 to suppose 1500. But I can say that it is again around 98, 99. Then once again, I try to change the sample size to suppose 2500. Then once again, I can see that, okay, the value is very close to plus minus 1 or 2 points from this 100. So that is giving me a reasonable idea that, okay, when I'm trying to take the sample size closer to 1500, my values are getting stabilized. And if I try to take the sample size to 1500, 2000, or 2500, there is not much change in the value. So I can say that, okay, 1500 is enough for me. And then I can say that under that type of setup, the sample size of 1500 will be enough for me. But definitely, in case if my parameters changes, suppose variances changes, or if other type of condition changes, then this value will also change. Right. So this is how I try to work. And this is how I try to take that, what can be the simple solution. You see, taking a sample size in a simple situation is pretty simple, but when you are trying to deal with the data science where the number of observations are pretty high, complications are more actually. So can we then simulation is one of the way by which you can get a good idea that how your procedure is going to work with the what type of sample size. So that's my advice. Next question is to name a few extension like ChatGPT, Copilot, and within Excel currently only requires a data set and rest of the cleaning analysis they do on their own. Our task has been to reduce to only asking questions. If we have tools which does all analysis on their own, and will be our role left in making data-driven decisions after gaining skills of multivariate procedure, only asking question to chatbot with already trained ML models. When one door is closed, many doors gets open. Please discuss about some fields where we can use our learning. You see, very simple answer to your very complicated question. Who made ChatGPT? ChatGPT has come now, but if you ask me, 3 years back we had one project in which me and my colleagues at IIT-Kanpur, we had developed the ChatGPT. Yeah, the name was not ChatGPT, but it has a similar capabilities. That was to some project that we did it. And ChatGPT cannot do anything. Believe me, he is only a slave. It is only a slave. It depends that what type of input I can give to the chat GPT. Chat GPT has no capability to judge what is right and what is wrong. And my advice to you will be, you are a human being. You are born to help others. You are born to create chat GPT. You are not here to follow the chat GPT. I can give you an open challenge. You go to chat GPT, I have tried, and you ask, who is Shalabh? And then whatever information it gives you, then you decide whether can you believe on chat GPT. Chat GPT does not give you any idea that what is right and what is wrong. Those people who don't know statistics, possibly they can use chat GPT, and whatsoever outcome it is given, they have no options except to accept them that they are correct. But believe me, there will be many instances where the answers may be wrong. But then you will not have a capability to judge whether your answers are right or wrong. In order to judge whether the answers given by ChatGPT or similar like of softwares are correct or not, you need the training on statistical tool and other sciences only, which can be done only by a human being, not by ChatGPT. Right. So don't depend on ChatGPT much, and otherwise the life will become more with more troubles. And many times it will put you in a very embarrassing situation. Yes, if you want to use this chat GPT, yes, you can use it in the way that it will reduce your time for doing many things. It will save your time, but it cannot be 100% dependable source. When you are talking about the data cleaning, right? How to clean the data is the biggest question. Means every data will have their own types of problems. And I can guarantee you that even if you try to put the data blindly into any of the software and if you try to clean the data, I cannot depend on the data after that, that what it has done. Means if I know the basic fundamentals, I would like to decide myself first that what cleaning has to be done. Where is the means you have to clean only that part where is the problem. And first you have to identify that where is the problem. Right. So these types of automated softwares are good for those who don't know the process. For example, means I don't know how to decide for a medicine. So I will go to the doctor. Means I will never ask a chat GPT, and I can challenge if somebody has a complication and if a chat GPT gives you a suggestion for a medicine, if he or she is going to really use it. So chat GPT is your obedient good servant, good helper. Try to take only the help, but don't give the decision making power to chat GPT. That is my final conclusion or final concluding statement to you all. Right. So no, the door is closed means doors will always be getting open and closed. That is only you who has to find that which is the correct door to open to get a solution. Next question is, Sarah, if we want to play with real credible data set to apply our learnings, which would be some of your suggestion from where we can get real life data set? Yes, that's a good question. Right, you see, actually, there are several websites which try to host the data, the real data set. I can't remember the names of those sites, but if you go to Google and try to see, then there are different websites which are hosting the real set of data. For example, one data set which we used. Actually, I think a couple of years back when we have that COVID, then I have attempted to forecast the COVID, And then we had written a paper in which we have used the real data set, which was coming from a website whose name is something like One Word, right? So they were giving the real data set, and they had the data set of the past also. So similarly, if you try to see, I can't recall the name, but several US universities are hosting these type of real data sets. Right. So I would say that try to take data set from there, and then there is no guarantee that one data set will work for all. It all depends that if you want to practice such a thing, that what type of data they have and whether that data is suitable for your given problem or not. But definitely some of the real data sets, they are also given inside the R software also. I have not use them because my objective was to show them that how are you going to work. I have used a built-in data set from the R only, I think, if I remember correctly, in cluster analysis and principal component analysis. But also I have taken a small data set because my objective was if I try to take a smaller data set, possibly I can show you that what's really happening, and after that it is your turn that how you want to use it. But in a bigger data set, I will not be able to show you that what exactly I'm trying to do. So that is why you can get them. And for your practice for this multivariate course, my strong suggestion will be that within the R software, you will see there are many real data sets. And in order to know that how to get them, those data sets, for example, if you want to do the cluster analysis, try to look for the help on cluster. And then if you try to go into the menu, they will mention there couple of data set on which you can do the cluster analysis. So this is how you will get a experience of working with the real life data set. Right. So now I don't see any more questions. So we can stop here. But thank you very much. It was really an interesting discussion, and thanks for asking the challenging problems whose solution I never thought before I started this live session. But definitely, I always say that a teacher can improve only if the students are good. So I'm really happy and I'm proud of you that all my students whom I have not seen, but they are very good that I can judge from your questions. Yes, your questions were very challenging, and I hope that I have answered them satisfactorily. Yeah, one that question about ANOVA and COVA, you can send an email to me. I will share you some link from where you can just go through very easily and you can understand it. This is not a question which I can answer in one line. Right. So thank you very much. You enjoy your course. If you have any questions, you can just put them on the forum. We always try to check. And yeah, all the best. Good luck. God bless you all. Thank you very much.
Thank you, sir. Thank you so much.
Thank you, Pranay.